pula dia nak record. Okay dah, boleh record. Okay, so I repeat it again. The ordinary differential equation, ODE, involving only one single, one independent variable. One independent variable. Okay, so we can identify the independent variable and dependent variable by looking at the differential coefficient. Is if our differential coefficient is dy over dx, that means our dependent variable is y and our independent variable is x. Okay, so ordinary differential equation involving only one independent variable. But for partial differential equation, okay, involving more than one independent variable, and the symbol also different. PDE. Okay, ODE we use a symbol dy over dx, but for PDE we use a symbol del. For example, like this, del u over del x plus del u over del y plus del u over del w, for example, equal to 0, for example, like this. Okay, for example, so this is a partial differential equation. Remember when I said if we write like this, del u over del x, our dependent variable is on the top. In this case is u. So in this case, our solution is a function of u with respect to this one. This is a independent variable. This is also independent variable, and this is also independent variable. So we try to find the solution that in function u with respect to in terms of terms x, y, and w. We try to find this one. Okay, so we have more than one independent variable. So in this case, we have three independent variables. So our equation here, we call it as a partial differential equation. So I hope now you know the difference between ordinary differential equation and partial differential equation. Okay, any question? Is it clear? The terms ODE and PDE. Any question so far?
Clear, sir.
Okay, clear.
Clear, sir.
Okay. Okay, so that is the difference between ODE and PDE. Okay, next is a linear or non-linear. For ODE, if for ODE, we can categorize into two types of equation, either linear or non-linear. If ODE, and this is only we focus on the ODE, linear or non-linear. So basically, the standard form of linear equation of ODE is like this. It's like this. Okay, I write it again. This is a linear, linear ODE. Linear ODE, the standard form. Okay, the standard form. The standard form is a n x d to the power of n y over d x to the power of n plus a n minus 1 x. Okay, d n minus 1 y over dx n minus 1. Okay, plus blah 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 till we have a1 x dx, oh sorry, dy over dx plus a naught x y equal to fx. Okay, so this is a linear. How we want to identify is it linear or not? Check on this what I circle here. This one, the coefficient, the differential coefficient. This is the differential coefficient, and also this y. Okay, if all the power to for us to consider our ODE is a linear, all these differential coefficient and including y, the power must be equal to 1. Power must be equal to 1. Okay. This is d to power n y over dx to power n power of 1. This is power of 1. This is power of 1. This is power of 1. So if all power of 1, then we consider there is a ODE. Sorry, it's a linear. Okay, that is the first condition. That is the first condition. The second one, okay, is okay. This one must a function. All these function or terms in x must be a function in terms of x only. Okay, must be in terms of x only. This is only in terms of x. This is also in terms of x. The coefficient for this differential coefficient must be only in terms of x. Okay, only in terms of x. This is also in terms of x. This cannot exist y inside that terms. Okay, so that is the second condition. Okay, so if all this in terms of x, then it's a linear ODE. For example, let's say this one, e to the power of x dy over dx equal to x squared. Okay, is this linear or not linear? Linear or non-linear?
Non-linear.
Non-linear.
Yes.
Why? Why this is non-linear?
Because there is a power of 2.
Very good, Justin, but your reason is wrong. Your answer also wrong. Okay, this is the terms that cannot be power of 2 is only y. Y dy over dx. This one also cannot power of 2, must be power of 1. But the rest, the terms, the function, this one can power of 2. Can be power of 2. For this one, if we write in the standard form, this is actually your a1x dy over dx. Okay, this is equal to fx. Is it x squared is a function, is a terms in terms of x only? Yes. Okay, fx, this one can be the power can be more than 1. Okay, but this one y cannot be power of 2. dy over dx cannot power of 2. For example, like this. This one is a non-linear. For example, d to the power of y over dx to the power of 2. Power of 2 plus e to the power of x y half equal to sine x. This one is a non-linear. This one is a non-linear. Why? Because the coefficient, because the differential coefficient d to the power of 2y over dx to the power of 2, the power is equal to 2. And this one, y also power is half. It's not equal to 1. So this is non-linear. This one is a linear. Okay, I hope this is clear. The power of y, okay, not the power of x, the power of y, okay, must be equal to 1. The power of dy over dx must be equal to 1. This one, the power must be equal to 1. This one, power must be equal to 1. Okay, Justin, is it clear?
Clear, sir.
Okay.
Thank you, sir.
Okay. Any question about is it linear or non-linear? Linear or non-linear? Any question? Any other question? No? After this, we will look at the examples so we can test our understanding. Okay. Next is the order. Okay. The order. Okay, the order. So if you look at this linear ODE, if this is the standard form, this is the standard form. This is a linear ODE with the order n. How we want to identify the order? You must look at the highest. Huh? Tak ada eh? Saya tak share ke? Eh? Oi, ada yang tak boleh tengok eh? Anybody? Why my screen didn't change? I okay, I'm waiting for you. Huh? Share another content? No, I just share only one note. Justin, I just share one note only. Can you see the cursor move on like this? It's okay. 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 So how we want to identify the order of the ordinary differential equation? How we want to identify the order of the differential equation? By looking at the highest coefficient. Okay, the highest differential coefficient exists in our equation. Okay, for example, this one. Okay, this one. This is the ODE, ordinary differential equation. Why? Because we have only dy over dx. Okay, and it's a linear. The order for this equation is first order. This is a first order. Why? Why this ODE is a first order? Because the highest differential coefficient exists in our equation is a dy over dx. Okay, dy over dx. But for this one, this is still ODE. This is still ODE, but non-linear. I already give you the reason why is non-linear. But for this ODE, what do you think? The order. The order for this equation.
Second order.
Second order. Very good. This is a second order. How do we know? Because the highest differential coefficient that exists in our equation is a d to the power of 2y over dx to the power of 2. Okay. So in our syllabus, we just come out with the fourth order. Fourth order. But for the first chapter, we just only focus for the first order only. Okay, so that is I think for now you should know how to identify ODE versus PDE. PDE. Okay, you should know, identify how we want to identify is it ODE or PDE. Number two, you should know to identify is it if ODE is it linear or non-linear. Linear or non-linear. The third one, the order. The third one is the order. How we want to identify just by looking at the highest differential coefficient that exists in our ODE. And the last one is how we want to identify the independent variable versus dependent variable. Okay, so this is four basics. Maybe we can say the knowledge about the ODE. Okay, so before we move to the example, any question?
No question, sir.
No question, eh? Okay. So if there is no question, we try to look at maybe a simple example. I just take from the notes that I give it to you. Okay, this one. Can you see the example?
Yes, sir.
Okay. Okay, now. Okay, we try to answer this question. Very simple. Together. Okay. Classify is it ODE or PDE, linear or non-linear? Give the order, indicate the independent and dependent variable. Okay, the first one. The first one. Is it ODE or PDE? First question. ODE or PDE?
ODE.
Okay.
ODE.
IOBE. Okay. ODE. ODE. Mana IOBE pula Okay. Okay. ODE. Okay. ODE. Okay. First one is a ODE. Okay. Because we use a symbol D, not a del. Okay. Is it linear or non-linear? Linear or non-linear?
Linear.
Linear. Okay. Very good. Linear. Okay. The order?
Second order.
Second order. Okay. Second order. Okay. Very good. Second order. Okay. Now, the independent variable. What is the independent variable? What is the dependent variable? What is the independent variable?
T.
Okay, very good. T. The rest? Independent variable T, dependent variable X. Okay, very good. Okay. Independent. So I hope all of you get the idea how to get this, identify this independent variable and dependent variable, because sometimes student very stick with Y and X. So when we change the symbol, students sometimes make a mistake when write the answer. Must remember, in this case, we have a dx over dt. So our final answer should be x in terms of t. You must remember this. Okay. Okay, that is the first question. Second question. ODE or PDE?
ODE.
ODE. Okay, ODE. Is it linear or non-linear? Justin said linear. Aisha said linear. Anybody want to try? You must have a reason, You must have a reason. Muhammad Hazim also said linear. Jing Ji Lee also said linear.
Non-linear.
Non-linear. Why you said non-linear?
Because to be linear has to be in terms of only X.
Yeah, but we have a Y here. We have Y here. So if you want to make it clear, we try to write into the standard form. In this case, is a first order. Okay. So the standard form of first order is a a1x dy, in this case, dy over dx plus a naught x y equal to fx. Try to write into this standard form to identify is it linear or non-linear. Okay, so if we look at this question, dy over dx, this is equal to y 2 minus 3x over x 1 minus 3y. Okay, can we write this equation follow this standard form? That is the question. Okay, so we try to rearrange. We try to rearrange so that we have like this dy over dx. This is equal to 2. It's not equal. Minus 2 minus 3x over x 1 minus 3y. This is y equal to 0. So we try to rearrange so that we can identify is it a linear or non-linear. Okay, so if you look at here, what is a1x? What is a1x? 1. Okay, very good, brave. Okay, very good, Nora Mirza. What is fx? What is fx? 0. Okay, very good, 0. Okay, 0 is also a function in terms of x only. Okay, the polynomial power of 0. Polynomial. Okay, now look at here. This is only have y. We have y. Okay, so this one this one should be only a terms function in terms of x only. But if you look at here, there exists y here. So that's why this ODE is a non-linear. Okay, that is why it's a non-linear. This is a non-linear. Okay, is it clear? Any question before we move on?
Clear,
This
sir.
one, okay, clear, okay, okay. ODE non-linear. What else? The order, first order. Okay, first order. Okay, first order. Dependent variable and the independent variable. I think you don't have any problem to identify that. Y is a dependent variable. X is a independent variable. Okay, so that is the second one. The third one. Is it ODE or PDE?
PDE.
PDE, because we use a symbol del. PDE. Okay, very good. Okay, so we try to find a function u in terms of x and y. Okay, so in this case, our dependent variable is u and our independent variable is x and y. Okay, question number 4. Question number 4, this is a why you very love to say OBE? OBE. Brave. This is the ODE. ODE and not OBE. What is OBE? Objective based. That is the OBE. This is ODE, ordinary differential equation. So this is question number 4 is a ODE. Okay, question number 4 is a ODE. Okay, ODE. And the order, is it linear or non-linear? Linear or non-linear?
Non-linear.
Non-linear. Why?
Because power 4 and got y.
It's not because of power of 4. It's not because of this. This is not a power of 4. This is a differential coefficient. But it's a non-linear because this one, y to the power of 2. Okay. The reason must be correct. Kita tak nak kata orang tu betul tak sengaja. Non-linear, betul. The answer is non-linear, but the reason is actually you use a wrong reason. So the reason must be correct. Okay. So non-linear, why? Because we have y to the power of 2. The order, The order. So this is a fourth order. Okay, so it's come from this differential coefficient d to the power of 4y over dx to the power of 4. Okay, and the last one is, I think, it's very easy for you lah, to understand. Okay, any question? This is four basics, information that you, four basic knowledge that you need to remember. Okay, four basic knowledge. Can we proceed? Anybody have a problem to understand this four basic concept, four basic terms? Any question before we proceed? Can we proceed? Tak ada tak ada soalan Okay, so if there is no question, so we look at another another terms. Is another terms. Okay, terms is about the, okay, this one, the terms. This is still focus on the the terms. Okay, initial value problem, IVP, versus boundary value problem, BVP. IVP and boundary value problem. Okay, so what is the difference? This is just a terms. Maybe if I ask about this one, maybe in the quiz lah. In the test, in the final, we never ask what is the initial value problem, what is the boundary value. That is, we will more focus on the method. But this is just a terms. Maybe I will ask you in the quiz. Okay, so initial value problem. So when we call it as an initial value problem, when the condition we only use one independent variable value, the same independent variable. For example, if the condition gives you like this, y0 is equal to 2. Okay, y0 is equal to 2. This is actually, we need to substitute the value x equal to 0 and y equal to 2. Okay, another one is y prime 0 equal to 0. So in this case, it's actually x equal to 0, y prime is equal to 0. So we use the same value of the independent variable. Okay, x equal to 0. The second condition is also x equal to 0. Okay, so we call this as a IVP, initial value problem. Remember, we apply the condition after we solve the ODE. Okay, remember that. Okay, we just use the condition just after we solve the ordinary differential equation. Okay, we will use this condition to find the integration constant, integrating constant. So we need this condition to find the exact solution. Kita akan gunakan syarat ini untuk mendapatkan pemalakameran, yang mana jawapan akhir dikenali sebagai penyelesaian exact equation. Exact solution. Penyelesaian khusus. Okay. So for the second one, if we have y pi equal to 0, that means x equal to pi, y equal to 0. If in the question we give you this condition, you must use this condition. If not, you will lose maybe 2 marks. So it's very unlucky for you. For this one, y prime pi is equal to 1. That means x equal to pi, y prime is equal to 1. So we have the same, and we have the same value of the independent variable. That's why we call this as an initial value problem. Boundary value problem, we use a different value of an independent variable. We call it a boundary. For example, if we mark this is a x, since we use a different value of x, so it's look like the boundary. Okay, a different value of x. For example, y1 equal to 4. This means x equal to 1, y equal to y equal to 4. Another condition is y2 is equal to 7. So this means x equal to 2, y equal to 7. So this is a different value of independent variable. So that's why we call this as a boundary value problem. Okay. Any question about this, about the terms initial value problem and boundary value problem? Any question?
Okay, so
Still okay? Or I explain a little bit faster?
still okay.
Still
Okay, sir.
okay.
Clear.
What about the rest?
Clear,
Only
sir.
Justin and is it your name is Kumarisan? Kumarisan. The rest okay? Still okay
Okay, sir.
Okay so kalau ada masalah ke apa bagi tahu. Jangan simpan dia. Okay. Okay, so if still okay, so we move to the first part of the first chapter. Okay. So look at this. We start with this one. Okay. We start with the syllabus. General form of first order ODE. General form of the first order ODE. The first chapter we will more focus on the first order ODE. So the general form of the first order is like this: dy over dx. This is equal to fxy. Okay. So this fxy, maybe sometimes can be if our fxy is in this form u y over vx. That means we can separate the 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 upper part. The upper terms is only in terms of y only, and the bottom part is a terms only in x only. Okay, we can separate like this, or maybe like this: vx over uy. Maybe sometimes like this, or maybe like this: uy multiply with vx, like this. Okay, so if your fxy in this three form, like this, so maybe after this we will look at the first one. Okay, so the general form of the first order ODE, dy over dx equal to fxy, we can classify into four types. This is a basic first order lah. The first one is maybe separable. Second one, homogeneous. The third one may be linear. The last one is a exact. So if you can identify the equation, so it can help you how to solve the ODE. You will find the suitable method to solve the ODE if you can identify the types of the ODE. Okay, so the first priority is a separable. You must remember the first priority is a separable, because if we use a separable, it's very easy for us to solve. Sangat senang kalau dia adalah boleh dipisah. Dalam bahasa Melayu panggil boleh pisah lah. Separable. If we can write in this three form, it's a separable. Kalau tak boleh pisah, jangan dipaksa-paksa lah. Okay. So we will look at the first types of first order separable first order ODE. Okay, look at first types of ODE. Okay, this one. The definition and how to solve the separable first order ODE. Okay, all this note you can get from the WhatsApp group. I just explain. I don't want to write wasting our time to write all these things. You can just print, but maybe you need to have a proper book notes, so that you can write everything that I explained here. Okay, this is just a very simple notes, but I will explain everything here. Okay, so the definition and the solution of the separable first order ODE. A differential equation is called separable if it can be written as this one. Okay, if this is the general form of the first order. Let's say dy over dx equal to vx over uy. Let's say like this. Okay, let's say like this. Okay, because this is in terms of x and y, so we can write as a general fxy. Okay, fxy. But if this fxy we can separate into this form, v is only a function in terms of x only, u is a terms only in y only, so we can separate. So the next step, we just separate. We just put every terms with y, contain y on the left side of the equation, and where is the terms involved have a terms x, we put on the right hand side. Okay, so we write like this: uy dy equal to vx dx. So this is the second step. Okay, so the left hand side of the equation only contain the y terms only, and the right hand side of the equation is only have a terms x only. So what is the next step we need to do is we need to integrate. Okay, integrate. So this is, if you are very strong, if you have a very strong knowledge about the integration, this can help you to solve this ODE. Okay, so it's very important to score this subject. You must have strong knowledge about the calculus, differentiation and the integration. Okay, so must very important. Okay, if you have still have a books in the engineering maths one, so better you refer it again. Okay, so on the left side we need to integrate with respect to y, and the right hand side of the equation we need to integrate with respect to x. Okay, so if you integrate this one, integrate both sides, and then if there is a condition, you need to apply. After you solve this integration, you need to apply the condition, so that you can find what is the value of the constant of the integration. And then you can write what is the solution, y equal to blah blah blah. Okay, so it's very easy. If we can identify it's a separable equation, it's very easy for us to solve. But make sure you have a strong knowledge about the integration. How many methods we can use to solve the integration? Anybody want to share? How many methods to solve the integration that you learn maybe from your secondary school, or maybe in your from matrix, or maybe from your STPM, or maybe from your diploma program, or maybe in the engineering maths too? How many? 3 methods. Aisha said 4 methods. Basically, what is can you name it? Some of the method. What is the method? The technique. By part, yes. Fitri said one method. Integration by part. Very good. Tabula method. Tabula method and the integration by part is actually same. Okay, partial fraction. Yes, very good, Muhammad Najmi. Substitution. That is the first priority. Substitution. Very good. Substitution is the priority. The first priority in the integration technique. If there exists some substitution that we can simplify our integration, we will use that method. Okay, very good. Okay, so seems that you have a very strong knowledge about this integration. Very good. So maybe you can score. Hopefully, maybe this semester all of you can get A. Okay. Okay. So we go to the example. Alamak. Alamak. Sorry. Dia dah jadi bengong kejap. Alah. Sorry. Kejap. Dia bengong sekejap. Okay. Now we try the example. Okay. Can you see the screen? The example. Can you see the example? The example question? Okay. Okay. Can Okay. We try to solve this together one by one, maybe if we have a time. Okay. Okay. We try the first one. Dy over dx. This is equal to xy. Okay. So this is very clear. We can separate. Separate into the left side. We have a dy over y. This is equal to x dx. Okay. So next we need to integrate with respect to x on the right side, and we integrate with respect to y on the left side of the equation. Okay. So what is the answer for this one? Integration dy over y. Anyone want to try? What is the answer? Dy over y. Integration dy over y. Ln y. Okay, ln y plus c1. Okay. Equal to. Okay, now integrate x dx. X dx. So what is the answer? X dx.
X square over 2.
X squared over 2. Okay, very good, Justin. Very good, Griff. Okay, plus C2. Okay, now C1 and C2. C1 is a constant. C2 also a constant. So we can combine C1 and C2 to become a new constant. So our final answer, let's say ln y equal to x squared over 2 plus A, where A is actually C2 minus C1. Okay. So this is your final answer. So in the next in the future, you don't have to write C1 and C2 lah. Just automatically you can combine. We consider that only have one integration constant. Okay, so this is a final answer. If you want to simplify, okay, if you want to simplify, make sure your method is correct. And sometimes student, when you want to simplify the answer, from the correct answer become a wrong answer. So please be careful. So if you want to simplify your answer like this one, ln y equal to x squared over 2 plus a. So how we want to remove ln so that our answer is only y? How we want to remove ln? How you want to remove ln? Take a exponent. Take a exponent both sides. Okay, take an exponent both sides. Okay, so we have e ln y equal to e to the power of x squared over 2 plus a. Is it correct? Is it correct? Is it correct? Yes, very good. So this is what I write. This one is wrong. Should be like this. Plus a. Everything move up. Okay, everything move up. Okay, so now we can simplify. This is e ln y. This is now betul. Okay, so now this is y equal to e to the power of x squared over 2 e to the power of a. Najib, ni betul tak Najib? Betul tak ni? Salah. Betul. Satu E cukup. Satu E cukup Plus A. Apa salah plus A pula? Mana ada plus A? Tadi plus A dah salah dah. Kata salah. Najib kata salah tadi plus A. Ni betul. Ni betul. Yang ni betul tak? Is this correct? Tu dah plus A tu Aisyah. Tu plus A kat atas tu. Okay, this is actually e to the power of a. A is a constant. So e to the power of a is a constant. So we can simplify our answer just like this. Y equal to b e to the power of x squared over 2. This one is correct. This is also correct. This is also correct. Because this is plus is actually e to the power of a. Okay. So your solution y in terms of x. Okay. Macam kalau kita ada e to the power of x plus y. This is actually equal to e to the power of x, e to the power of y. Okay, dah harap lah. This is a multiplication. So that is an index. The knowledge that I think you already know before this. Okay. Okay. So that is the first question. Any question regarding the first example? Any question? Nur Dalila, any question? Dalila ada soalan?
Tak ada sir.
Tak ada. Okay, tak ada. Okay. Okay. No question Okay. The second one. Okay, the second one. Okay, the second one. Okay, we try to solve the second one. Question number 2. dy over dx plus y sin 3x plus 2e to the power of x y equal to 0. Okay, I give you a chance to solve this. Maybe 5 minutes. 5 minutes I think is good enough to solve this question. Okay, try. 5 minutes. Then maybe if you want to share your answer in the chat room, you can write your answer so that we can check together before I show you how to solve it. Okay, 5 minutes. Try. hopefully all of you take part in the discussion lah. So at least you know your knowledge, basic knowledge. So every single question is actually I show you just to refresh your knowledge about the calculus, about the integration. Try. Yeah. Yeah.
GPA, NTTI,
Oh, is it?
pra-GPJ, dah lulus.
Tak payah ambil test.
Ambil lah. Ambil pra-GPJ macam
Test lah.
tes macam
Untuk
okay.
apa? Untuk motor.
Gitu.
Oh. Ya
Biasa
tadi.
kira,
Ya tadi.
okay, mana ada. Apa? Stop. Okay,
Tunggu tes. Tunggu tes.
Kira macam dah layak untuk PJ lah.
Oh,
Tes tu. Jadi kalau dia tak lulus, kena belajar balik lah. Ini kat mana dah? Di sini ni. Tapi baru level D lah. Level D.
tak apa. Apa label D? D tu.
D untuk kereta.
D untuk kereta apa label D? Memang D untuk kereta.
Yelah, masa baru level D. Sebab motor komputer tak lagi.
Okay, finish. Anybody want to share the answer? Anybody want to share the answer? Any question? Any question? Did you face the problem to solve? I think it's very simple. I think very simple. Anybody want to share the answer? No? Anybody finish? Answer this question. What is the first step that we need to do here? Anybody want to share? What is the first step? We try to do this together. What is the first step? Rearrange. Okay, rearrange. Okay, rearrange. Very good. Rearrange. Okay, maybe rearrange and factorize. Yes, very good. dy over dx, this is equal to negative y sine 3x minus 2e to power of xy. Okay, this is rearrange and then factorize. Okay, dy over dx equal to minus y sine 3x plus 2e to power of x. Or maybe you want to write like this. Y negative sine 3x minus 2e to power of x. This is also can. Okay, doesn't matter. Either this one or this one. Okay, just make sure you write the correct factorize. Okay, very good. Okay, is it we can separate? Is it we can separate these terms? Which one you want to take? Okay, so let's say this one we separate. This is dy over negative y equal to sine 3x plus 2e to the power of x. This one is as a dx. Okay, now we just need to integrate this one. Okay, integrate dy over negative y. So what is the answer here? This one, the first one. We integrate with respect to y. Negative ln y. Very good, Rahul. Okay, this one. Integrate sine 3x with respect to x. We can integrate one by one. Okay, integrate sine 3x dx. So what is the answer? Integrate sine 3x. So what is the answer? Anybody know? What is that? Oh, lajunya terror. Siapa tu Najib? Terror betul Najib. Power. Integrate sine 3x. Dapat apa? B kuasa negatif 2. Nanti compare Najib jawapan ni. Sin 3x negatif. Integrate sin 3x. Tak ada siapa ke nak jawab? Negatif. Okay, bagus. Okay, Nur Hamiza, hati-hati. Nur Hamiza, hati-hati. Integrate sin 3x. Integrate is not a differentiate. Integrate sin 3x, we will have a negative cos 3x over 3. You can check your answer. If you differentiate this one, you will get again sin 3x. You can check your answer. Okay, if you differentiate cos 3x, you will get negative sin 3x times 3. Okay, so you can simplify, then you will get sin 3x. Okay, that means this is a correct answer. Okay, plus 2e to the power of x plus a. So that is the answer lah. Okay. Okay. So if you want to simplify, this is equal to y. Sorry, ln y equal to cos 3x over 3 minus 2e to the power of x plus b maybe. Plus b. B is actually equal to negative a if you want to use. Doesn't matter. If you write plus a also can. Okay. As long as at the end, if there is a constant, if there is a condition, then you will get the final answer. You will get the same answer. Okay. So if you don't want to simplify, you can leave your answer like this. Either this one I accept, this one also I accept. Okay, doesn't matter. As long as your integration give me the correct answer. Okay, question number 2. Any question? Any question for the example number 2? Any question? No? Okay, so now we look at another example. Okay, the last one. Between question number 3, 4, 5 or 6, which one do you want to discuss? Question number 3, 4, 5, 6. Choose one question that you want to discuss. Question number 6. Really? Okay. Tak menyesal Tak menyesal Okay. Okay. Question number 6. Okay. Number 6 or number 5? Number 6 or number 5? Question number 6 is very, very easy. But okay, because since question number 6 is very easy, okay, we try to solve it lah. The easiest question I will show you. The hardest question you do you try by yourself. Question number 6. Okay, question number 6. E to the power of 2y cos x dy over dx. Is it correct? Cos x dy over dx equal to e to the power of y sin 2x. Okay, we try this because before we solve another question. Okay, try first. Try first before I show you how to solve it. Try first. 5 minutes. Okay. First step is very clear that we can separate these terms. So this is e to the power of 2y over e to the power of y dy equal to sine 2x over cos x dx. Okay. Any question? Any problem? How we get this one? No? Okay. So now we can simplify. This is e to the power of y dy equal to sine 2x over cos x dx. Okay. So how we want to this one? We integrate this one. Okay. Now the answer, the integration for e to the power of y dy, we will get e to the power of y. Okay. Any question? How I get this e to the power of y? No question, eh? Okay. No question? No question. No question? No question. Okay. This one. Okay. How we want to simplify this? This is sine 2x. This is cos x. How we want to simplify this integration before we integrate? How we want to simplify these terms? Any idea? Brave already. Take 2 out Take 2 out very good Miza. Senang betul siapa yang cakap bawa keluar 2 tu Najib. Kau bawa 2 keluar. Macam mana Jib boleh bawa keluar? Takkanlah jadi macam ni Jib. Ya Allah. 2 sin x Jib. Mana boleh Jib? Tak boleh Jib. Salah Jib Everything inside the sine or the cos or the ln, the tangent, you cannot simply take it out. Okay. Jangan saja-saja bawa keluar. Okay. Okay. Brave, no Amiza, no Dalila, very good. You give the correct answer. Okay, the correct step. Use the identity. Okay, sine 2x is actually 2 sine x cos x over cos x dx. So this we can simplify this one. It's actually we just need to integrate 2 sine x dx. Okay, so finally our answer is e to the power of y equal to 2 cos x. Don't forget negative plus a. Okay. Any question? Question number 6. Any question? Question number 6. Any question? No. Justin, multiply with ln. Multiply with ln. Multiply with ln. Do we need to define a in the working? What do you mean define a? What do you mean Rahul? Define a? Apa maksud kamu define a? You don't have to. You don't have to write like that. Just give the write only one integration constant. Okay, just plus a. You don't have to write a equal to c2 plus minus c1. You don't have to. Okay, so that is question number 6. Question number 5 is actually the hardest one. It's actually question number 5. Okay, the new method dy over dx. Okay, question number 5, dy over dx. This is equal to x e to the power of x plus y with the condition y0 is equal to 1. Y0 is equal to 1. This is the question. Okay. So now, is it separable? Is it separable? Okay, is it separable? Yes. Okay. So epsilon can separate epsilon. Why we need to epsilon? This is actually dy over dx. This is equal to x e to the power of x e to the power of y. We don't have to take any ln. This is actually equal to dy e to the power of y equal to x e to the power of x dx. So integrate apa C7 tu apa? Fahmi? Apa setuju? Ya Allah, pemalas betul tulis setuju. Se7 je setuju. Hai, budak-budak apa ni? BBNU budak-budak baru nak up Alamak, kau punya short form pening aku baca. Kesetuju. Pemalas betul tulis setuju tu. Setuju Aduh. Pening bala. Okay. So, last one. This is the last one. Okay, integrate dy over ey. Kita dapat apa? What do we get? Integrate dy over ey. Ln ey. Is it correct? Is it correct? Integrate dy over ey. Ln ey. Is it correct? Is it correct? Is it correct? Betul tak tu? Integrate dy over ey. Is it correct or not? Not good. Aduh. Tak sure. Alamak. Nasib baik saya tulis benda ni. Bagi korang fikir. This is wrong. Jangan ingat apa yang bahagi je. Dy per je terus jadi ln. Jangan macam tu. So this is actually, you can simplify. This is actually e to the power negative y dy. Okay, so this is integrate x e to the power of x dx. Okay, so integrate e to the power negative y. This is actually negative e to the power negative y. 1 over. So this is negative e to the power negative y. Just is e to the power of y is actually e to the power negative y. Okay, any question? Any question? This one. Boleh tak? Ni simple je ni, puasa-puasa ni. Okay, any question? No? No? Okay. So, hopefully there is no question lah. That's why I give you this, like this one. Hopefully none of you give the answer ln e to the power of y. There is a wrong. Don't assume everything when you have like this dy over y ln y, that is correct, but y squared, this is not ln y squared. Jangan anggap asal bahagi je macam tu terus ln. Bagi je ln. Salah. If this one, you need to change y negative to dy. So you can use a power, the integration of power. So it's very easy. Okay. So hopefully you can remember that. Okay. For this one, how to solve this integration? Any idea? Any idea how to solve that integration? Yes, integration by part. Okay, integration by part. Remember the integration by part? Integration of u dv, this is equal to uv minus the integration of v du. This is the formula. So you need to choose what is your u and what is your dv, and make sure when you choose u and dv, your integration become simple. Okay, this can simplify your integration. You must choose u and dv that make your integration much more easier, not much more harder. Okay, so in this case, you choose u is equal to x, dv equal to e to the power of x dx. So du over dx, this is equal to 1. And this v is actually, we integrate e to the power of x. And finally, this is actually e to the power of x. So we substitute into this formula, integration by part formula. So this is actually uv. Your u is x, your v is e to the power of x. Minus integrate, your v is e to the power of x du. This is actually du equal to dx. So this is dx. So finally, your final answer is negative e to the power negative y equal to x e to the power of x minus e to the power of x plus a. Okay, any question? Okay, any question? This is the last, the final answer? Okay. Remember, you have a condition. This is an initial condition. Y0 is equal to 1. Okay, substitute into this equation. So you will have negative e to the power negative 1 equal to x is equal to 0. This becomes 0 minus e to the power of 0 plus a. So a equal to, this is equal to 1. A is equal to 1 minus e to the power of minus 1. If you want to write that. Okay, and don't leave your answer like that. If you want to use your calculator to find this value, yes, you can. But if you don't want to use calculator to get this value, you just can write like this. The final answer is negative e to the power negative y equal to x e to the power of x minus e to the power of x plus 1 minus e to the power minus 1. That is your final answer. Okay. Any question for the separable equation? You already finished a separable equation. No question. Justin have no question. What about the rest? What about the rest? Any question before we stop our class? Okay. Stop presenting. Stop recording. Stop recording. Stop recording.